Lesson 47, antimatter, and this lesson starts off with you going to YouTube and watching this video. I love this video. It's only 2 minutes, but it's exciting. It's tense. It's got a twist ending. It's got everything you want in a YouTube video. Matter versus antimatter. So please watch that video, how the universe works, and then come back to this. But in the last lesson, left you kind of hanging a little bit, kind of intentionally. Let's just talk about that. In the last lesson, we talked about cloud and bubble chambers, and the example that we did, we had something with no charge producing an electron. That's not black. An electron and a positron. Actually, we're going to put positron as just, we'll do this. An electron and a positron being an anti-electron. And the question is, what did they come out of? Where did this electron and this positron come from? Well, you might have thought, well, in previous lesson, you said that a neutron was actually a proton and an electron. So a neutron, if this was a neutron going this way, it wouldn't make any visible path in the cloud or bubble chamber because it's neutral, it doesn't have a charge. And then if it's split up into an electron and a proton, then it would do this. But remember that the proton has a considerably greater mass, so the radius of the proton down here would be extraordinarily large compared to, if I had to draw it to more to scale, it would look more like this. That's not even to scale. There's the electron, there's the proton down here. So this is not an electron and this is a proton. What did it come from? So what is the neutral particle that created this electron and this positron? And the answer is, it wasn't a neutral particle, it was a photon, and a photon has no charge. And you're going to learn in this lesson about antimatter and about this particle-antiparticle annihilation. And when we learn about that, then that will answer the question of this. Okay, so what's antimatter? Antimatter is very simply, you've watched the video, so you know what antimatter is. For every particle, there has to be an antiparticle, or we theorize there must be an antiparticle. So for an electron, there's an anti-electron. For a proton, there's an antiproton. For a neutron, there's an anti-neutron. And the antis just basically have the opposite characteristics. So it says the first antimatter particle discovered was a positron, or you can call it an anti-electron. And then here's the symbols we use. So there's your electron, there's your positron, there's your proton, there's your antiproton, a neutron, and an anti-neutron. And usually with the anti, we just put a line over it. So remember this, a neutrino, antineutrino. Yep, remember that from radioactive decay. Okay, then we come to this. Antimatter has some interesting qualities. When matter and antimatter collide, a process called particle-antiparticle annihilation happens. In this process, two particles causing the total destruction of each other, transforming all of their mass into energy by this equation here. So that's pretty insane. If you met your anti-particle person and you collided with one another, all of that mass would be converted into energy. And let me tell you, that would be a huge amount of energy because we have a great amount of mass. So here we go. Now we can look at this problem right here. Oh, what the heck happened here? Can I erase that? Yes, I can. I didn't expect to see that. Antiparticle. So here is a particle-antiparticle annihilation. It does happen in stars. One such reaction involves an electron and a positron, and they collide. And they collide, they annihilate each other and just become pure energy. So all of their mass is converted into energy, and that is the equation. Positron plus electron equals 2 gamma rays. Assuming the gamma photons are identical, determine the energy of one of these photons released. So we're just going to use the equation E equals mc squared. Now, what mass are we going to use here? Well, an electron and an anti-electron are just going to be 9.11 times 10 to the negative 31 times 2. Because an anti-electron and electron have the same mass, they just have opposite charges, times the speed of light squared. And you get 8.20 times 10 to the negative 14 joules. Oh, sorry, and that's then you've got to multiply it by 2, so it's actually 1.64. My apologies. 1.64 times 10 to the negative 13 joules. You don't really have to do this, but that produces, I'm just doing it so that it makes sense in terms of this equation here. So there's the mass of one, there's the mass of the other. That's why I multiplied it by 2. And that produces 2 gamma rays. This equals 2 gamma rays, or gamma photons, and we want to determine the energy of one of those. So you just end up dividing your answer by 2. That's why I said you don't really have to do that, multiply by 2, but just to make everything make sense, I think it's better that we do, because now we divide it by 2 and then we get the final answer, which is 8.20 times 10 to the negative 14 joules per gamma ray or gamma photon. All right, which again may not seem like a lot of energy, but we're talking about 1 electron and 1 positron. Then it goes into some interesting stuff about PET scanners. If you ever go to the hospital and you have a PET scan, it is positron emission tomography, and you can read about that, where you get injected by fluorine-18, which is radioactive, and it decays in your body, and blah, blah, blah. It's all absolutely fascinating. CERN and antimatter, there's a good video on that, which, oh my gosh, this is my favorite meme. Antiparticles, the ultimate star-crossed lovers. Okay, if you are not laughing, if you're not busting a gut right now, you have failed this course. This is absolutely hilarious. It's obviously a reference to Romeo and Juliet, because as soon as the electron and the positron touch, they will annihilate each other. Absolutely hilarious. Okay, is that it? Oh yeah, and then the only other thing I want to say for this lesson was we just did what happens with an electron and a proton, and a positron collide. They annihilate each other, but the opposite can also happen. You can get gamma rays producing an electron, so they can just spontaneously, gamma rays can just spontaneously produce an electron and a proton, positron. Sorry, saying the wrong thing. Positron. So the reverse can happen, and that's that previous example that we just did, this one right here. That's what's happening right there. What's coming over here? It's a gamma ray. A pair of gamma rays are producing an electron and a positron, right? Energy converted into matter, matter converted into energy. E equals mc squared. The energy matter equivalence, it goes both ways. You can convert matter into energy, or you convert energy into matter. That ends the lesson on antimatter, and it all matters.